So graphing linear equations 2. In this video, we're going to look at f of x. Now, f of x is equal to y. Just jot that down in your copy off to the side. F of x is equal to y. So y is equal to x plus 2, which would give us a very, very similar equation to what we were dealing with in linear equations 1. Now, the domain, if you picture domain, so these little key things, when you know them, make maths easy. Domain is the x-axis. So if you picture the x-axis between -3 and +3, that's what we're going to have. So my y-axis would split that down the middle. Okay, so 1, 2, 3. We're going to put the numbers on this time. -1, -2, -3. That one's a bit too close. There. Now, we don't know my y values yet. So what we're going to do is we're going to create a table. And this is what we'll be doing in quadratic equations. So I'm just setting you up for graphing quadratics by doing this. We're going to put our x values in. What are my x values? -3, -2, -1, 0, 1, 2, and 3. I'm going to put them into my equation, my inputs. So these are my inputs over here beside x. My outputs are going to be what comes out of this. So I'm going to do some lines just so we can separate the numbers. So how many parts to the function do we have? Quadratics will have 3 most of the time. We have 2 here. We have an x and we have a +2. So if this was 3x, this was a 3x, we'd multiply 3 by -3 and put a -9 inside this box. But we'll get there with those ones. We're starting off simple. We'll build up to the more difficult ones. So my x values are just all my x values. So I'll do them in a different color. So my x values are -3, -2, -1, 0, 1, 2, and 3. And this 2 is a constant. We've seen that before in the algebra videos. So there's nothing to multiply it by. So we put +2 all the way down. And my y values, which I'll do in black, are a combination of what's inside the boxes. Add red numbers. So -3 + 2 is -1. So if we continue to add these numbers, -2 + 2 is 0. -1 + 2 is 1. -0 + 2 is 2. And you can see a pattern here. Next number is 3. Next number is 4. Next number is 5. So we have a series of points here. -3, -1 being the first one, and 3, 5 being the last one. And as we said in the last video, we only need 2 points to draw a line. So in math, a lot of the time we do want to take some shortcuts in an exam situation to save us some time. So let's plot these 2 points, and we can see now the range of our y values. We're going from -1 as the lowest value up to +5 as the highest value. So -1 is here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And let's plot our points. -3 on the x, -1 on the y is approximately here. Probably actually a little bit higher. Let me just change that. You guys are going to have used the ruler to measure a centimeter for the x-axis, which I'm going to label. And you're going to use the lines on your page for your y-axis. Or if you're using box paper, you'll have the same scale on the x and y. The last point that we're going to put on is 3. So here's my 3. Now, if I can do a dotted line up to 5. Approximately my 5. Now, I'm going to take one more point. Where across is the y-axis and where across is the x-axis? There are 2 more points. -2, 0 is this point. And 0, 2 is this point. That's what we were looking at in graphing linear equations 1. Now, you should see that my line goes through all of those points. You're going to use a ruler and just draw it once. I'm just doing it a little bit heavier so you can visualize where all the points are. And you can see minus 1, 1 would be here. 1, 3 would be here. 2, 4 would be here. And 3, 5 is on the line. Now, some students will graph every point. One of them could be here. If you get a point there and the rest of them are on a straight line, you know you're wrong. But I would recommend get the first point and the last point and make sure that your intercepts, the y-intercept, the x-intercept, and the y-intercept are correct. Now, continuing with this question, what if you were asked to graph f of x minus 2? So, what would happen? All our values will come down by 2. Now, I'm at 5 up here. If I go down 2, I'm going to be at 3. I'm at 4 here. If I come down, I'm going to be at 2. And so on. I'm at 2. I come down, I'm going to be at 0. And if I'm at minus 1 and I come down, I need 2 more points here, down to minus 3. So it's called a shifting of the function. If we take a number away from our f of x, we still have a graph we can draw. It just has dropped 2. It's gone down 2. You can see that difference there is 2. And similarly, if we were asked to graph f of x plus 2, you can see exactly what's happening. Pause the video and draw that line for me. Okay, so maybe start with the 2. That's going to go up to 4. My minus 1 here down the bottom is going to go up to 1. And if I take my 5, it's going to go up to 7, which is approximately here. And as I said to you in the last video, that's put down what the graph is, f of x plus 2, f of x, and f of x minus 2. So I'm going to give you one to practice, try it, and then move on. Okay, so try this question. Graph f of x is equal to minus 2x plus 4 in the domain minus 2 less than or equal to x less than or equal to 2. Your x-axis, your y. Pause the video and graph this. So, let's do our table. We have our x values. They're minus 2, minus 1, 0, 1, and 2. So a little bit smaller than the last one. Only 5 values to put in. That's a bit of a squiggly line. So, x, y. What have we got? We have a minus 2x and we have a plus 4. So, distinguish the values that you're going to add together with a different color pen, because a lot of the time the mistake that people make is they add all 3 of these boxes together instead of just 2 of them. So minus 2 by minus 2 is 4, minus 2 by minus 1 is 2, minus 2 by 0 is 0, minus 2 by 1 is minus 2, and minus 2 by 2 is minus 4. So you can see a pattern within those numbers. My constant stays the same. There's no x attached to it. 4 plus 4, let's do them in blue. 4 plus 4 is 8. 2 plus 4 is 6. 0 plus 4 is 4. And you can see the pattern is going down 2 each time. 2 and 0. My points, minus 2, 8. And 2, 0. So let's have a look at what this looks like. So you should have identified your highest value of y is 8. In here, your lowest value is 0, so we don't need any negative numbers. You've used a ruler, unlike me, and you have put your minus 2, minus 1, 1, and 2 on the x-axis. So let's have a look at these points. Minus 2, 8 is approximately up here. I think it's important to get the intercept. When x is 0, y is equal to 4, it's this one. So we want to go through the intercept at the correct point. And the last point is 2, 0. So I'm just taking 3 of my 5 points, and now I'm going to connect the dots. And that line I'm going to just take it away because it is a restricted domain, so we just have to graph it down to 2. You could be asked to find the area of this triangle within a question. So it's not just about graphing the function, it's about looking at the graph and seeing what's happening. What would the area of this triangle be? Half the base by the height. What's the base? 2 is correct. And the height? 4. Half of 2 by 4 is 4. And what we would write is units squared. Or instead of writing the word squared, if you don't want to have to write it, we could write a little squared there. Okay, now graph f of x minus 2. F of x minus 2. Okay, so you've paused the video. How many points did you put on? Everything is coming down 2. So my 4 is coming down to 2. My 8 is coming down directly down to 6. And my 2 is coming down to approximately minus 2. Approximately minus 2. Maybe a little bit further. So in green, you've graphed f of x minus 2. This one was f of x. So graphing linear functions in the form f of x, functions, tables, shifting up, shifting down. Hopefully you have a good knowledge of graphing linear functions.